Okay, today we will have maybe 4 hours workshop which start until maybe at 5 p.m. And then in this first question, I would like to thanks to Antonis, Prof. Antonis that facilitate this program is part of our program in collaboration with maybe 7 universities in ASEAN and 5 partners in European Union. So this program is actually already started in 1990 200 sorry 2019 2019 maybe Prof Antonis 2019 and now we maybe in 2018 Pak Tum when we went to Yunani at the time 2018 yeah. Oh yeah. Oh, 2019. I think we start this program, and now this is at the end phase of our program. And this workshop is maybe a series workshop. The first workshop is conducted maybe in Thailand, Vietnam, and then Thailand, and the last before in here is in Toulouse, France. And today we will continue our workshop for Indonesian country. And here, because in Indonesia we have 2 institutions, ITP and UGM. So probably for the first, we would like to invite our head of department from Department of Electrical Engineering and Information Technology to deliver the welcome remark. Please, Dr. Hanung Adinugroho as our head of department for giving your welcome remark.
Thank you, Dr. Sartio. Can all of you hear my voice here? Is it clear?
Yes, clear.
Okay, thank you. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon to Antonis, Sikakis, and all of you. This distinguished ASEAN coordinator of MESfIA and distinguished MESfIA project officer, distinguished representative of ITB Institute Teknologi Bandung, distinguished ASEAN University representative, distinguished partner, guests, colleagues, researchers, professional ladies and gentlemen, and all of you. First of all, it's a great honor for us to welcome all of you to this workshop and training for trainers of MESfIA program. Currently, our department, the Department of Electrical and Information Engineering, Faculty of Engineering, Universitas Gadjah Mada, in collaboration with Bandung Institute of Technology, ITB, along with 4 other universities in Southeast Asia and 5 higher education institutions in Europe, are incorporated in the MESfIA program co-funded by Erasmus. As the implementation of this collaboration, the Department of Electrical and Information Engineering, UGM, has enhanced the current curriculum of Electrical Engineering Master Program to meet the MESfIA expected learning outcome. The enhancement this enhancement is conducted by developing several elective courses, which is relevant to the specific competencies as mentioned in the MESfIA program. And the enhanced curriculum also with addition of specialist competencies to support the electrification for isolated areas. As we know that electricity becomes the basic needs for the human being for supporting many activities. For example, in this pandemic era like this, the necessity of electricity is high, very high, for supporting online classes, meeting, webinar, and it's like what we are doing today, meeting. However, many people living in the remote area, they do not have sufficient access to the electricity. the remote area, especially in the east part of Indonesia. And we would like to express our gratitude to Power System and Renewable Energy Integration Research Group at the Faculty of Engineering, Universitas Gadjah Mada. The chief is Dr. Sarjia, and also one of our partners from Indonesia, the ITB, Institute Teknologi Bandung, for co-organizing this event, and also the EU for sponsoring this project, because without this fund, this project or this workshop may not have been held. And our sincere thanks also to the keynote speakers for this event, for making tremendous contribution, and above all, thanks to all partners for their support and guidance, and all of your participation. We hope that you can enjoy and mutually benefiting from this workshop, and we hope also that this program can run very well and smooth until the end. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Hanung, for giving the speech. And I think it's very thanks because this program is currently supported by department, and one of the kind of the support for this program is we have a co-funding scheme for the procurement of Typhoon. This is, I think, today we will have special session for giving the presentation about Typhoon from the Typhoon representative office in Singapore, and also from Dr. Ronnie, who will deliver about how to use the Typhoon for development of the material of lab work and also for teaching material. Thank you again, and now we will have welcome remark from the Idp Institution. Pak Denny, please, if you have or other colleagues from IDP who will give the remark.
Okay, very much, Dr. Sarjia. So thank you very much for hosting this workshop as inter-country Indonesia. And also good morning. Good morning to Antonios. Professor Antonios there in Greek, and good afternoon for my fellows, my colleagues, and also in UGM and here. And yeah, good afternoon. So it's very grateful to be here in these workshops. So I think this workshop will be beneficial for all of us, for our close collaboration, especially in the future. And I think so we can share our experience in developing MESfIA curriculum. Yeah, if we can with this collaboration with the other types of activities like the student exchange or research collaborations and other stuffs. And so here I have in these workshops, and I hope that they go very much from our experience. Our institution, yeah, for giving us the to make in the future. So thank you very much for Dr. Sarjia as well in this workshop. Thank you very much.
Okay, thank you, Pak Denny, our partner from ITP. And now I think the time for Prof. Antonis to deliver the introduction about the MESfIA program to all of us, because in here the participant is mostly maybe student from UGM and so from, but also there are maybe some participant from non-MESfIA members, some of university in Indonesia. Please, Antonis, this time is yours.
Yes. Yes. Thank you all of you for this active participation in the project, and I guess that you can see my screen now. Is it? Yes, you can see.
Yes, you can see.
Okay. Well, I'm the MESfIA project, and it happens to be from another island territory of the world, the island of Crete. And I'm very happy that I was able to meet our Indonesian partners in Crete, and at least one of the travels that we made from this was actually in your island, in Java Island. So we exchanged visits at least between our both islands. This project was an action within the Erasmus Plus funding of the European Commission under the KA2, capacity building in the field of higher education, and we wanted to cooperate for the innovation and exchange of good practices. The budget was amount to 1 million, taking into account the most traveling we had. That's why it was that high, but actually it happened to have 120,000 euros for equipment in the 6 SN institutions. The project is to an end at May 2022, but the master programs will remain here. And in order to do this work, we needed preparation phase, a development phase, a quality plan, dissemination phase in order for those actions to be known to people, and of course some management. This is a global project because we start from west as the Canary Islands and the UK to east as Yogyakarta and Bandung. We do have partners from 3 countries in Southeast Asia, 2 from each country, 1 from France, and 2 from Greece. And this is the list of educational organization in France, universities in Thailand, ASEAN Institute of Technology and Engineering Department of the Australian University, 2 universities in Vietnam, the Non Lam University in Ho Chi Minh City, and the University of Technology and Education in the University of Da Nang. And our hosts for today, Universitas Gadjah Mada from Yogyakarta and the Institute of Technology of Bandung in Bandung, and both of them in the island of Java in Indonesia. What is our objective? To provide high quality postgraduate education on energy supply systems for engineers and graduates from departments that would like to have activity or employed in countries with many isolated areas and the insular system. These trial MSCs that have been involved with the aid of the project, and we would like to join to have some other higher education institutions willing to undertake similar actions. What are these isolated areas inside? Physical islands, large island power networks like the one of the island of Java. Medium power systems, so smaller island power systems like the island of Santorini here in Greece. Very small island power system with very few people living there. We have got examples from island regions. This is, I think, from Vietnam. This is from Vietnam. We have isolated, but network. You see here in the desert, You see here in the jungle, you see here in the Nepal with the wind turbines. And another issue that we should take into account is that we need resilient power systems for temporarily isolated. Here, due to snowstorms, something is not known to you, but hurricanes or heavy rain may be known to you, and therefore these areas may become isolated due to problems in the infrastructure caused by a natural disaster. The expected outputs are to realize the difficulties in isolated environments and the peculiarities with energy management of such systems. We need engineers to cope with these difficulties, to have the capability of difficulties, to establish this European Union and Asia cooperation at regional level in island regions. We are a project with island region in Canary Islands, Greek Islands, and Indonesian islands, not to mention other isolated areas in Vietnam and the Thailand. So these problems require common solutions, and the young generation of scientists should be aware of the potential solution. The outcome should be to transform existing master programs to targeted master's programs, so that your title will make you capable of saying that we are experts in improving energy supply conditions in isolated areas among all the other knowledge you have granted from your professors in Indonesia. Okay, what we expect from this workshop will give the opportunity to students and other stakeholders, mainly in Indonesia, but also in other Southeast Asia countries, to learn about the suggested MESfIA curricula, especially in the partners universities, in UGM and ITB. They will check out the laboratory acquired and the laboratory available for their studies. Some of these have been funded by the European Commission. Special focus will be given on the Typhoon hardware in the loop installations. The participants will be able to understand the problems in isolated areas by presentations performed mainly by members of the consortium in Indonesia. And bear in mind that we had, as Professor Sarias has stated, presentations from other workshops available in our website. Our motto as a project is that common problems require common solutions. You can see on your left our project visit to the installation of the dispatching center of the island of Crete. And on the right-hand side, you can see our visit as a consortium to the West Java Kamonjan geothermal power station. The workshop in Badung, all the discussions, the conference, all of the activities we had have stated that common problems require common actions. And this is, I would say, our motto for the project. So thank you for your attention. You can follow us in the Facebook page. You can see introductory lessons in the YouTube channel that you can find here. Terima kasih. Thank you for your attention.
Okay. Terima kasih, Antonis. Thank you very much.
Okay.
Yeah.
I don't know if anybody from the ASEAN Institute of Technology has, you know, oh, we have 56 participants, so we have to search a little bit. Very nice. Very nice that we have so many participants, and I believe that it will be a very successful workshop.
Yeah.
Okay.
Okay. Thank you,
I
Antonis.
don't see our project officer presentations from your side, and then continue on with the flow. And if he connects the call, it's now the time in Brussels, 8:30. So I don't believe that he will be in his office earlier than 9. So he will make a room later on within the day.
join in here or not, because if are you here, Prof. Ahmad? It seems that he cannot join in this workshop. So because not Kumar cannot join in this workshop, so the welcome remark from AIT things can be skipped. And now we move to the next agenda, that is the presentation about the implementation of the MESfIA curricula in each of the program, the consortium member. So the first is on behalf of UGM, I would like to present the implementation of MESfIA curricula in Master of Engineering, Electrical Engineering in UGM. Please, Mbak Erina, can you present the slide? Okay. Belum ini ya. One moment. Belum. Oh sudah. Sebentar, sebentar. Okay, I would like to present about the implementation of MESfIA curricula in UGM, especially in Master Program of Electrical Engineering. As informed by Antonis regarding with the program, is especially would like to increase the skill and knowledge and also the expertise of the graduate and postgraduate student. So the student can handle the issue related with supply of insulated area. And so the outline of our presentation is, first I would like to address the issue of and the challenge of electric supply in Indonesia, especially because Indonesia is one of the maybe the biggest supply country in the world. And then I would like to what kind of skill and knowledge related to the energy supply for isolated area, which are supported by MESfIA PLO or program learning outcome. And then based on the MESfIA curricula, we would like to explain the adoption of this curricula to enhance the existing curriculum of our master program. And then I would like to also explain about the implementation and the of the program. This is, I think, a common issue maybe in archipelagic country like Indonesia, because we have more than 17. Oh, sorry. Gimana caranya? Sorry. Sudah. Okay. Yeah. Okay. This is the issue and challenge in especially as archipelagic country. because we have more than 17,000 islands, and most of the islands, especially in maybe in eastern part of Indonesia, Maluku, Papua, and Nusa Tenggara, there are so many challenges to supply the isolated area with reliable and then also with high quality of the electricity supply. I think in the next session, Dr. Tumiran will explain in more detail about what kind of the challenge to develop the power system like in eastern part of Indonesia, because so many islands in there. And then the issue also because most of them is electricity ratio is relatively low compared with other area in Indonesia. And then most of them now is supplied by diesel-based power plant, with of course with the increase of diesel fuel, the cost for providing the electricity is higher and higher. And then PLN now already launched the program which in Indonesia we call as de-dieselisasi or de-dieselization program, which the objective is to reduce and if possible to replace the diesel power plant with local renewable energy resources. And if we talk about the providing electricity in the isolated area or small scale area, microgrid is one of the system which can be used to provide this kind of supply by combining the local renewable energy resources and then battery energy storage with existing diesel or probably other kind of maybe power plant like maybe gas or other, will the potential for supporting the reliability, continuity, and cost reduction of electricity for isolated area in Indonesia. And then to answer the maybe the problem according the quality of the engineer, because there are so many islands, which mean that also there are so many engineers to be dispatched in those locations. So I think this very important to provide the engineer who can handle the issue of electricity in isolated area. This is the MESfIA program learning outcome, which already designed by the team. So in UGM, we would like to we try to implement this MESfIA PLO in our existing master program. And this is our actually existing Master of Electrical Engineering program in UGM, which to finish to get the graduate level, the total credit is around 40, and then this consists of maybe compulsory subject or compulsory course, and then selective compulsory, and then elective course, and then seminar and thesis. Because this adoption of MESfIA program cannot be implemented or cannot be adopted in the compulsory subject, because it needs a long process to modify the compulsory and selective compulsory subject. So UGM adopt this MESfIA curricula by adding two courses in elective course, that is renewable energy integration in power grid, and also the other course is design, operation, and control of microgrid. This is, I think, the way we can adopt this MESfIA in our existing program. And then this is the adoption of MESfIA curricula to enhance the existing curricula in our master engineering program by additional to elective course. And then for your information that this courses already offered maybe for 2 years, last 2 years, and one of the course is design, operation, and control of microgrid has been had twice, because the other course maybe because there are limited number of students, and so the limited number of courses can be offered. So the course that's already implemented is the design, operation, and control of microgrid. And then in here we also would like to inform that in the funding scheme from the MESfIA, we can procure the Typhoon Hill 604, which this Typhoon is one of the powerful simulation software and hardware that we can use to simulate in the design, operation, and control of microgrid in real time. So the procurement of this hardware and software is by supporting the European Union with also the funding from UGM, because this is co-funding scheme. And in here today, we would like to hear the explanation from the Typhoon maybe office from Singapore, the Genetron, who would like to present about what kind of Typhoon and how it can be used in the control and operation of microgrid in the real-time operation. And Dr. Roni also will explain in how to develop the module or material in teaching and lab work by using this kind of equipment. Okay, I think this is the implementation of MESfIA curricula in UGM. And then we would like to invite Pak Denny. Please, you can maybe present how the implementation of MESfIA in IDP. So this time is yours.
Yeah, thank you very much, Dr. Gadjah. So first, I'd like to share my slide. Could you see my slide there?
Yes, we can see.
Okay. So once again, thank you very much, Dr. Gadjah, for the opportunity. I'm Denny Hamdani, ITB MESfIA coordinator. Present very short presentations on the development of MESfIA curriculum at ITB. So I have actually 15 minutes. So the first 5 minutes, I will share our experience to develop this curriculum, and then my students will further with the experience with the equipments. So yeah, we are very grateful that we are involved here in these programs, the capacity building in field of higher education on the mastering for isolated area. And as you know, that these projects takes 3 years supposed to be, like extended 6 months because of COVID-19. So actually in developing these curriculums, the toughest part actually not only these COVID situations, okay, but also the bureaucracy so in our institution. So because before we are going to that in details, we start of course with the program objective of this program. So as here we can see that we have to establish a number of master courses in the very solid curriculums that combine existing experience EU and ASEAN countries. And of course, the transfer of knowledge between countries is in renewable energy potential is the focus. And then so we are trying also to explore the intelligence energy educating high for specialists in risk management. So as Dr. Gadjah presented earlier, so we try to derive the PLOs of our master programs technically from these main issues, from managing of energy resources in isolated power systems until the financial economic tool for funding, extending this power supply for isolated areas. So yeah, actually we have done a lot of things, okay, to implement programs. So this is what we have done in promote our also programs, also start the kickoff meeting of course, and workshop in Bandung, and we try to disseminate in so in public media, social media, and as you see here, we have also flyers, so that presents the of these programs that here in Indonesians we try to produce the human resource pioneer and specialized in designing and developing the sustainable electrical energy systems, especially in isolated area, in comprehensive and technical and non-technical aspects, and then push the students to have communication skill and collaborative effort through the between institution, and then to enhance the quality of the graduate educations, and with the very strong research orientation. Of course, the other important outcomes is to produce much possible the international scale so scientific this collaboration, and is our dream is to have center of the area. So all of the PL actually here and implement this the curriculum of MESfIA started with the workshop, okay, and kick-off meeting of MESfIA, and then here we have to convince the faculty that we have a very good proposal or programs to offer here, and it takes some time to get the legal formal also from the institutions, and during that we try also to make it public and promote, and okay, try to select or started to selection process, and then we try to start the programs almost the end of the first year. Okay, so here in ITB we call this MESfIA master program as TEL, Technique Energy Electric Berkelanjutan, or Sustainable Electrical Energy Engineering, under Master Study Program Electrical Engineering. The one of the bureaucratic problems. So if we make this program as an option under this master study program, or option focus, so just research focus. So we have to trade between the flexibility in the arrangement of the curriculum and the difficulties of the process. Okay. So actually in ITB we have 36 credit for master program. So consists of 12 credit for compulsory courses of master study program here, electrical engineering, and then and the rest, so we can play with the rest of the credits. So 9 credit for compulsory courses of options, which is electrical power engineering, and 15 for optional courses of options, okay, from electrical power. So this is the choice. So if we want to make this program as an option, so we have to change the curriculum structure. So this is for us very beneficial because it's more flexible in the arrangement of courses. But according to ITB's statutes or regulations, so this is kind of a major change. So it means that we have to go through a long path until the university academics. So it must it's supposed to take times, yeah, minimum 12 months. So I think it's not possible. So what about option or the next choice of track? So in the track, we can change the course syllabi. See, this is like flexible in the arrangement of courses, and but the category of change is minor. So here, it means that the path of the approval is quite shorter until the rector. So maximum 12 months. So I think this is not also possible because we have not much time there. So and then we try to propose the other choice is very novel courses, but it also needs approval until faculty academic senate. So 12 months. So also it's we are quite tough. That's why we decided to make this program as research focus. So under option electrical power engineering with faculties existing courses. So this is the position for our program in our institution. So with this this choice, we can go forward without any approval. So here the so we have developed many type of curriculum according to the choices. So as an option, we have this kind of courses curriculum. So the yellow ones that's from this 12 credit for electrical engineering study program. So this is a must courses from ITB for master program. And then actually we want to to have a core or compulsory courses here from our strategy. Okay, as you see that actually we have already some courses that exist, then and check and we can check as our courses, but the others must be the new one. So the ones with this X signs. Okay. So this is the curriculum of from CIS as an option. So that's so time it's not possible. So that's why we decided CIS as the focus. So as you see here, as the focus, we have to take the all of courses here also come from the existing ones. What we can do is just enhance some chapter of the courses that relates to MESfIA. So and about the equipment, I think my student will cover it in very detail. So we have both. So thank you for MESfIA, for Professor Antonios, that gave us this very nice equipment. So we have solar energy advanced training equipment that consists of inclinable PV panel, and then this is sun simulator, and this is the modules which has 9 or 10 of experiments that we can go here. So as far we have 10 master students that involved in these programs, as you see here, some of them, and then this is, and then we have also published 4 paper at MESfIA conference, and what good things we can use it as for the collaboration with other AU programs and energy access. So we have also envisioned that this MESfIA program will be recognized widely as a national widely recognized master programs in this very specific area. Okay, and then yeah, we hope that we can have a national scale research center. So thank you very much, and then we can go forward with my students. I think we have 5 minutes, Professor. Yeah.
Okay, please.
Yeah. Okay, I stop. Sorry. Okay.
Okay.
Yeah.
Thank you both of you for this very explicit explanation of how you have structured the curricula and the subjects that have been developed for the MESfIA project. I don't see our project officer to be here, so perhaps we can move as we have planned and allow some time later on.
Sorry, Antonis.
I do not see our project officer here. Therefore, we can proceed with our schedule, and if he connects, then we give him a time slot.
Oh, okay. Yeah. Yeah. I think Pak Denny will need more time because
it's nothing for equipment. So please,
okay, please, Pak Denny.
Okay. Thank you for the opportunity. I will go to screen share.
Yeah, please.
Okay, hopefully already shown in the screen.
Yes, we can see.
Okay, thank you very much. Hello, everyone. I am Haris Hartman. I am graduate students from Institut Teknologi Bandung. In this great opportunity, I would like to give explanation and demo about photovoltaic solar energy advanced trainer equipment, which is given by the Mastering Energy Supply focusing on isolated areas, or MESfIA, funded by Erasmus Plus program of the European Union. So in the next slides, we can see the contents of this advanced trainer. The first of this, sorry. The first one is the sun simulator, this one with the halogen lamp, and then inclinable photovoltaic panel, which is the angle can be suitable with the setup of the experiments, and then 3-level frame with several modules, and then the last one is the battery. So the sun simulator consists of, the first is box controller, which is the bright of the halogen lamp can be set up. This one is the experiment that already conducted, and this is the halogen lamp. So the inclinable PV panel consists of, yes, PV panel or the PV array, and irradiation and temperature sensor. And then the last one is the inclinable brackets. And then this is the three several modules, which is in the next slide will be elaborated. This one is the energy measurement, the main supply to supply the energy measurement, and then battery control model, on-grid or grid tie inverter, AC loads, DC loads, protective module, active load, charge regulator, DC AC inverter, and AC electrical measurement. So this is the level 1, consists of 4 modules. Energy measurement or DL9021, it measures DC and AC electric parameters, solar irradiation and panel temperature. This one is the module. And then main supply, this one, DL9032, oh sorry, this one, DL9032, it provides 240 VIC and 12 volt DC. And then battery control module, DL9041. This module is used to disconnect the battery from the rest of the circuit. And then the last one is on-grid inverter, DL9013G, DC input and AC power. So the level 2 in the module is AC load, DL4236. Manual control using local switch or control through the Modbus protocol. Oh yeah, this module can be controlled with the software from the Lorenzo. And then DC loads, DL9044, to DC loads, LED lamp, low current halogen, and high current, this one. And then DL9031, protective module, this one. And active load, DL901HA, working in the CC mode or current control mode. The set point is used to define the desired current, and the module keeps that value independently on the applied voltage. The last one is the level 3. There is charge regulator, electronic module for charge regulation of the battery with the current supplied by the solar panel, and then DC inverter or DL913, and then the last one is AC electrical measurement. And the battery is for general purpose application for the storage. And then in one case, I got one case for the research, which is still in the study, measuring the generated power of a PV system, energy balance of an off-grid system. Yeah, the PV array in the roof, on the roof of a house converts the photovoltaic energy to electrical energy, but the sun is not always bright, so need charge regulator to regulate supply to the battery, which could supply DC loads without the inverter. Yeah, the C line. And then the inverter convert DC supply to AC loads, this one, for house general electrical equipment. So this is the schematic of the experiment. This one not in the real house, but this one gives some of understatement about how to balance the energy that's supplied to isolated areas. Yes, this one is encouraging the students, especially we studied the renewable energy, because the renewable energy, the challenge is for the balance of energy for the supply. So this one, some of the gallery of the experiments. And thank you. And the last one, I will share the demo video. Please wait a minute. Okay, 3, 2, and 1. Hello, everyone. I am Haris Rahman. I am graduate student from Institut Teknologi Bandung, Electrical Engineering Program. This great opportunity, I would like to give demo about the solar energy laboratory from De Lorenzo. So we can see here there is halogen lamp as the substitutes for the sun, and then a PV array to convert the energy from the sun to electrical energy. And then here's the several modules, and then the PC, which is the software will run to execute some of the program. Okay, so let me turn on the light and show the module works. So we have to switch the breaker and then select the locale to this module, and then I think enough to 50 more. So this halogen lamp substitutes the sun and make the array got light, and we already wiring this connection from the module. So here we can see how the modules run. And here is how the software works. Like we can see some of measurement, same as like in the module from the several module. And we have the CD software which already installed, so the software can run. Okay, everyone, thank you for your kind attention. Hope this demo will give some insight of what we have done. Thank you very much. Bye. Okay, thank you very much for your kind attention. I give back to the host.
Okay. Thank you, Mas Aris, for very nice presentation about the equipment which has been used in ITP with support from the MESfIA. Okay, now I think we can move to the next session.